Good morning students. Welcome back to the channel. In today's video, I will show you how to retrieve ligand data from PubChem and organize it into a structured research table, so which is extremely useful for molecular docking, drug screening and computational biology studies. Okay, so if you are working on protein ligand docking, drug repurposing or structural bioinformatics, so this tutorial will help you standardize your ligand dataset professionally. So let's quickly jump into the things. So first, let us try to understand what is PubChem. So PubChem is a free public chemical database maintained by NCBI. Okay, so it gives information about chemical structures, physiochemical properties, different file formats of the molecules, and 3D conformers, bioactivity information. Okay, so before performing docking of any of these biomolecules or small molecules, it is essential to collect accurate ligand properties and data, and PubChem is one of the most reliable source for this. So what data we are going to collect? So let's have a quick look at that part too. So whenever you are collecting any information about any small molecule, irrespective of its source, so you need to collect the name of the ligand, the PubChem ID, molecular formula, molecular weight, canonical SMILES, hydrogen bond donors, hydrogen bond acceptors, rotatable bonds, TPSA, total polar surface area, and XLogP, which talks about lipophilicity, and then Lipinski rule of 5, which talk about the drug-like properties of a small molecule, and structure of the molecule in 2D format, so that you can paste it here. So now let's go to the PubChem and navigate to one ligand and find out all these properties and tabulate them. Okay, so here I am interested in a ligand called aspirin. Okay, type aspirin and then click on search. So you can see here aspirin. So just cross check whether you are accessing the right compound or not. Okay, so confirm the compound name, it is aspirin. So other name of it is acetyl salicylic acid, salicylic acid, and it has a compound ID of 2244 and molecular formula C9H8O4, and molecular weight is 180.16 grams per mole. So, and you can also see the SMILES format over here. So you can copy paste all this information as of now. So let's just do that first. So first name is aspirin, and what is the PubChem ID? It is 2244, and molecular formula is C9H8O4, C9H8O4. So convert them to a subscript. Okay. Then molecular weight is 180.16. So the units are already mentioned on the top, no need to write again. And canonical SMILES. Okay. So these are the different ways to represent the molecule. Okay. And next we have other properties. So these properties are called are grouped under physiochemical properties. Okay. So just click on this compound name. So it will navigate you to the web page of that particular compound, or the summary page of that compound. Then on the right hand side you can see the table of contents and the summary, and click on the physiochemical properties. Here you can find out hydrogen bond donors is 1, and hydrogen bond acceptors are 4, and number of rotatable bonds are 3, and you can see the TPSA value is 63.6 angstrom square, so no need to type the units. And the XLogP 3, that is 1.2, which talks about lipophilicity. And coming to the Lipinski rule of 5, it's not mentioned here, so let's first check. So it is usually not mentioned here, but here based on the properties, that is molecular weight, it should be less than 500. Okay, so try to remember the Lipinski rule. It is molecular weight should be less than or equal to 500, and hydrogen bond donors should be less or equal to 5, and hydrogen bond acceptors should be less or equal to 10, and log p value, that is x log p value, less or equal to 5. So if you see here, all the properties are satisfying the Lipinski rule of 5, right? And this one, so we are going to type yes. So if in case if there is any violation, so you could type yes, one violation. It means one of the property or parameter is not satisfying the compound. So the thumb rule here is that the compound should satisfy at least 3 properties. Okay, so then we can type, we can consider that molecule. And next thing is the structure. So this, as you have, let's navigate back to the PubChem. You can see there is in the summary on the right hand side, that is the structures. So you can download the image of the 2D structure. Okay, just click on get image. So you can go for the highest pixel, so it will be a good one. So the common things one need to avoid is that don't talk about the stereochemistry unless you have a good knowledge over that, and ignore the protonation states of the molecule, and check the Lipinski's rule parameters. Okay, and always ensure that you are selecting a biologically relevant compound for targeting your protein. Okay, so tabulating the information in this format gives a professional outlook, and it will also help the reviewers to understand the properties of the selected ligands very easily. Okay, so the thumb rule or to remember is that in computational studies, documentation plays a very important role. So you can insert the structures this way. So now the most important step is that click on the download button. So you have to download 3D conformer SDF format, okay, of the file for further use. Okay, so the smile format we have saved, and the 3D conformer format we have saved now. So we are going to use these formula or the files for further docking work. Okay, so if the 3D structure is not available, then you need to go for the 2D structure. So in this video we have learned how to search for compounds in PubChem, how to retrieve their physicochemical properties, so how to extract the data and tabulate it, and how to evaluate the Lipinski rule of 5. Okay, so in the next video we are going to cover how to convert the SDF files into required PDB files. Thank you for watching, and I will see you in the next session.